All right, so this is 11-8. This whole section is on word problems. It's actually pretty easy while you're doing it now, but the problem is that when you're given the word problems in like a standardized test or on a final or on, say, like, you know, your CSTs or the SATs, they mix the word problems up. So what you need to look for is when they put you in a situation where you are into a right triangle. When they present you with a right triangle and a missing side length. Anytime you're in a word problem that puts you in that situation, you're going to use the Pythagorean Theorem. So the question is not how to use Pythagorean Theorem, but actually when do we use it? Okay? So let's look at some situations that we can apply Pythagorean Theorem to. So the first one is, find the length of the diagonal for a rectangle that measures 3 inches by 4 inches. What's a diagonal, Izzy?
Isn't it the line that crosses from one point to the other?
From one corner to the next. Okay? So I'm going to do that, and I'm going to call it x because it's unknown. So now, what I've created here is a right triangle. Did they mention anything about Pythagorean Theorem? No, but because they have put me into a right triangle situation, draw what they're talking about. Okay? And I have a missing length side, that x. Now I'm going to just start using my Pythagorean Theorem. A squared plus b squared equals c squared. What numbers do I substitute in? Danielle?
3 squared plus 4 squared equals x squared.
3 squared plus 4 squared equals x squared. And we calculate it out. We get 9 squared plus 16 is equal to x squared. And then we get 25 is equal to x squared. We don't be rude, just root it. And we get x is equal to 5. Well, we can avoid the negative, right? That's what Scout asked me. Can we just start avoiding it because we are doing Pythagorean Theorem right now? Yes. We can avoid our negative values. Now, what does that mean, x equals 5? Take it back to the story. Lisette.
That means that the diagonal of the rectangle is 5 inches?
The diagonal of the rectangle is 5 inches. Okay? Don't give me x equals 5 in the answer column because I don't know if you know what x is. All right? Questions? Yes?
So what would we write in the 5 inches?
Diagonal equals 5 inches.
Or just 5 inches?
Can we just do x equals 5 inches?
5 inches, I would just abbreviate so that I know you know what it's talking about. Yeah, I guess you could do 5 inches. All right, next one. Find the length of the side of a square whose diagonal is 4 meters long. Now, what can I fill in here? Gwen.
Well, it would be a squared plus a squared equals 4 squared.
Okay, so what am I going to draw in this situation?
You would draw a diagonal.
Okay, and in that diagonal.
And you would say it was 4 meters long.
Okay, so that's 4 meters. And then what am I going to call this side?
X.
X. And this one?
X.
How do you know that they're both X?
Because a square is equal on all sides.
Right, a square is equal on both sides. So they're telling us that these are the same. And because it's a square, they have to be the same. So now I use my a squared plus b squared equals c squared. I substitute in x squared plus x squared equals 4 squared. Now what? Yes?
Wouldn't you would simplify 4 squared to 16, but then you would combine the like terms of x squared to get 2x squared?
Right. Now this, be careful here, because I have a lot of people saying x to the 4th. Remember, when it's the same base, we just add the coefficients. So this becomes 2x squared equals 16. Next step, yep.
We divide?
We divide by
2.
on both sides. and x is equal to 8. X squared is equal to 8. Now we take the square root, and x is equal to two numbers. Square root of 8 is equal to radical 4 times radical 2, which would be x equals 2 radical 2. That's the more exact answer. Or x is about equal to, what's the square root of 8 is between what perfect squares? 9 and 4. And so the square root of 4 is 2. The square root of 9 is 3. And I'm going to estimate it at about 2.9, 2.8.
And can you write that answer or that answer? Either.
I would like you getting used to doing both right now. I want you using those skills right now. Okay? Can I erase?
Yes.
All right, let's try the next one. Technical difficulties. All right, next problem. To the nearest tenth of a foot, find the length of the diagonal of the rectangle with a width of 4 feet and a length of 10 feet. All right, stop the recording, and you try this one on your own. You guys try it on your own. Go. All right, so let's check our work. You should have labeled the height 4 feet, the length 10 feet, and our diagonals unknown. We substitute in. We get the square root of 116 is equal to about 10.8, 10.7. All 0.5. It's not halfway in between.
What about like 10.6?
Nope.
Is that?
Nope.
Shh. All right. So these are both your answers. Yes.
Can it be 4 and
4,
no, 16 and 10?
16, and...
No. Never mind.
Okay.
On YouTube?
All right. Now, let's look at this situation. Okay? Draw what you see. Draw what you see. So look what I'm going to do. A car drives 20 miles east. I'm just going to draw. I'm going in the east direction. Right? And I'm going to say 20 miles. And then 45 miles south. Okay? To the nearest hundredth of mile, how far is the car from the starting point? So now, what's the fastest, what's the best, the shortest distance? Scout. The diagonal. Okay? And that becomes our unknown. And we set it up as the square root. Now, a squared plus b squared equals c squared. A squared is 20 squared plus 45 squared equals x squared. 400 plus 2,000. What is it, 2025?
Yeah, because
Okay, equals x squared. So then I get 2425 equals x squared. Now this is a huge number. And my first period said, gee, do we get to use calculators? No.
What? What do you mean no?
Okay? You don't get to. So, and I guarantee you're going to get this on a test. You're going to have a big number. You're going to get it in quadratics. And you're going to get it in the Pythagorean Theorem. And you've got to start coming up with ways that you can figure this out. So the first thing I'm going to do is I'm going to, I look at it. Is it an even number? Can it be divided by 2? No. So I'm not going to go with 2s. I'm not going to see how many 2s. What would you go with?
I would go with 25.
25 is the perfect square, and we know it ends in 25. Every 100 has how many? 4. So off on the side, I'm going to divide 25 and see if it goes evenly. And I'm doing 25 into 24, 25. Okay, it doesn't go into 24, but I'm going to say try 9. 45, carry the 4. It's 18, 22. Okay, that works. 10 would be 250. It would be too much. So 12 minus 5 is 7. And I'm going to have to break that down to 13 minus 2 is 11. No, yeah, 3 minus 2 is 11, is 1. And then I have to bring down my, now 25 goes into this 7 times. So it's even. So when I'm taking the square root of this, I get x equals radical 2,425 is equal to radical 25 times radical 97. Radical 97, radical 25 is 5. 5 radical 97 is equal to x. Now, what is the square root of 97? Can you estimate it?
Yes. 9.8.
So, figure about 9.8. So if I take 5 times 9.8, right? That's much easier because 100 is 10. So,
Or you could just kill that 9.7.
is 9.8 was a good guess. So now I'm multiplying 9.8 times 5, and that will give me my approximate answer for x. So 5 times 8 is 40. Carry the 4. 5 times 9 is 45, 49. So we end up with 49. So we have two answers. This one, or x is about equal to 49. Do you understand that's a 49, not?
You can write it.
Okay. Okay. So here I go. Next possible word problem. Look how far off we were. We were pretty close. 2/10. We were within 2/10 by our estimation. Okay, about 49. Okay, I'm just going to show you how to translate this. I'm not going to do the Pythagorean Theorem with you. Find the legs of a right triangle if one leg is twice as long as the other. How would I label it? Isaac.
Well, the hypotenuse would be 10.
Okay, so it says the hypotenuse is
And
10.
then the longer of the two legs would be 2x.
And the
shorter would be x.
Good. Okay. And so once I'm labeling those, I substitute in x squared plus 2x squared. Now, what does 2x squared simplify to? 2x squared, what does it simplify to? 4x squared. So just be careful with that. I had a lot of people. And now, when I have 4x squared and x squared, what does that come to?
5x squared.
5x squared. And equals 100. Divide both sides by 5. And x squared is equal to 20. Take the square root. It's less than 5. It's greater than 4. 4.6. X is about equal to 4.6 or 2 radical 5. Okay? But when we're talking about measurement, usually they want you to kind of give a estimated amount. Okay? Now, so the other thing is we have to go back to the story. Find the legs. So if one leg, this one's 4.47 or 4 47/100ths, then the other one we have to double that. Does that make sense? 8 and 94 hundredths. Okay, questions? All right, let's look at the next possible word problem. Okay, this is a typical Pythagorean theorem problem. They put you into the situation of a right triangle. A 12-foot ladder leans against a wall, just like this. If this is my ladder right here, this ruler, okay, and it's leaning against the wall. Now, how far must the base of the ladder be placed away from the wall if it is to reach a height of exactly 10 feet? So let's talk about the different parts. Okay? We say that this dark black thing is the what? That's the ladder. What's this down here? That's the base. And this is either the wall or the height. Does that make sense? So what numbers am I labeling these with? And notice it makes a nice little right triangle. Okay, Phoebe.
Well, it tells you right away that the ladder is 12 feet, so, and then also, it tells you that the height is 10 feet.
And so what's unknown?
The base.
And it says, how far away must the base be? So that's my x. Okay? So then we do our Pythagorean theorem. A squared plus b squared equals c squared. 10 squared plus x squared equals 12 squared. And subtract 100. X squared is equal to 44. Take the root of both sides. And x is equal to, we know that that's radical 4 times radical 11. So we could say 2 radical 11. That's the exact amount. Or, I can estimate it. Radical 11 is a little bit greater than, or let's go radical 44 is close to 49 and 36. It's closer to the 49 than it is to the 36. So about 6.7. I would take either of those. 6.6, 6.7. I got 6.6. So x is about equal to 6.7 is what we agreed on. That's within 1/10 of what my calculator shows. Yes. Because, okay, when I have the square root of, we're just estimating. We know the square root, the perfect squares are 36, and that's a 6. Not negative 6, that's just a dash. And then I have down here 49. Okay? So the square root of 49 is 7. Now, somewhere in between there, that's about, let's see, 49 minus 36 is 13 digits. So let's say halfway in between would be about the root of 6.5, right? That would have to be about 6.5 digits. So like figure 6 digits minus 6 would be the square root of 43. So you've got, the square root of 43, and you've got the square root of 42. 41, 40. You've got all these other ones, 39, 38, and 37. You with me? The other way, you got 43. This is about the halfway point. 43, 44, 45, 46, 47, and 48. So, you see how you have like equal amounts right there? They knew that it's closer to this than it is to this root right here. They knew it was more than halfway. All I'm asking you to do is be within the correct benchmark using that 1/2. So they knew it was more than 6.5 but less than 7. So some people screamed out 6.7. Some screamed out 6.8. I would have taken both of those. When I did the square root on my calculator, I got 6.6332495, and then the calculator cuts off. So it's estimated. This is actually, mathematicians don't even use this answer. They use this answer because it's far more accurate. Okay? All right. Guide wire questions. This is another typical Pythagorean theorem problem. A guide wire is needed to support a 20-foot pole. How long should the guide wire be if it is to be fixed to the ground 8 feet from the base of the pole? So we have to draw this. I'm going to draw a flagpole. Okay? I'm going to draw the ground. The guide wire goes from the top of the pole to the ground, the base. Okay? They want to know how long it should be. How long should it be to be fixed to the ground 8 feet from the base? So then we start naming our parts. How far should it be across? What's that distance on the ground going to be? What numbers am I placing in?
8 and 20.
8 and 20. Where does the 20 go?
20 goes on the flagpole.
20 is for the flagpole?
8 is for the space between the flagpole and the guide wire.
Right. So it's on the ground. That 8 goes on the ground. That's your base. The ground, 8 feet. It's attached 8 feet from the pole. And then our wire becomes what part of the triangle?
Hypotenuse.
Now again, the biggest problem is do you know to use Pythagorean theorem? Because they will not tell you. Okay? So then we do a squared plus b squared equals c squared. Substitute in. 20 squared. Actually, why don't you guys finish this one up? Finish it up. Pause the recording. All right, so now let's check our work. I'm substituting in for the a and the b, the 20 and the 8. An x squared for my hypotenuse. Should have gotten 464. I take the square root of both. And what do we get? 4 and 16. You're breaking it down. Okay.
And that's 4 and 29. 4 radical 29.
4 radical 29. Oh, look what they did. Okay, so let's... Okay, wait, what did you get? What do you mean 4 and 16?
4 and 1.
Well, first I got radical 4 and then radical 16. 116, that's what I meant. And then it's 2 radical 116, and then you break down 116, so it's...
So you got... Okay, so she's doing square root of 464. She broke it down to 4 times radical 116.
Yeah.
And is there a 4 in there?
Yeah.
Okay, so that would be 16 times what? No, 16 times what is the... Okay, but you said 4 times what equals... 4 times 29 is 116?
4 times... Yeah, 29 is 116.
Okay, so 16 times 29, right?
Why 16?
Will that go down to 2?
Because if I broke that down,
Yeah, okay.
4 times 4
Yeah, right.
time... Okay, 4 times 4... Wait, that wouldn't be here. It's just going to be here. I could either write it 4 times radical 29, or So then I would get 4, let's just do this. Let me erase that. 4 radical 29. Okay? 4 radical 29 is equal to x. Or we can take the square root of 464. I know the square root of, now look, big numbers. If I'm estimating, square root of, what are my perfect squares? The square root of 20 is 400. The square root of 25 is 625. It's pretty close to 20. I might try 21. So, 23 is what you got?
Wait, what do you mean?
Like 21, 25. 21 and 22.
It's between 21. I would have guessed 21.
Yeah.
So 21 times 21. So I would have guessed a little bit. But you know what? This is also an easier thing to do. Square root of 29, we can estimate that. Square root of 29 is less than 6, but more than 5. Maybe about 5.4. 5.4, so that we could do 4 times 5.4. Or 5.4. Okay. And that equals 4 times 5.4 is about 21.6. So 21.6 is about equal to x. Okay, so you have two answers here. 4 radical 29, or about, now if you look at my PowerPoint, they're going to be a little bit more accurate. 21.5. That was a pretty good estimate. So instead of having to find the square root of 464, okay, now I have one more problem I need you to do. Do not pack up. Don't shut your book. Okay, this problem really involves two problems. To find this diagonal, notice I've got this line right here. I know this line. So the line I'm missing really is here. Right? Now, that's 5. And that leaves me with two unknowns. This is unknown here, and this is unknown here. So before I can do that, oops, I have to find my, I have to find the dimensions of the bottom triangle. Now notice, this one right here is 5 inches because they're opposite. And this one on the other dashed line, we don't know what that is, but that other dashed line has to be, do you see it on the other side of that blue triangle? Has to be what? 6 inches. Okay, so this triangle that's blue, I have 2 out of the 3 dimensions. I have to use Pythagorean Theorem to find that. So I substitute in, and I get y is equal to 10. Okay, once I get that, then I have 2 out of my 3 dimensions for the red triangle. And I can find the diagonal, which is the hypotenuse. Okay. And I get about 11.2. And you can either put it in radical form or estimate it, and that's the end of the lesson.